In today's session, we are going to just briefly introduce you people to something new in the topic that is minerals. Okay, so today we are going to discuss what is this mineral, and then slowly we will come to that how to identify a mineral, what are the uses of these minerals, and how it is important for a civil engineer to understand the basics of a mineral and rocks. Correct. So you people must have heard about the term minerals. What does it mean, mineral? When I say the mineral, first thing that it may be coming to your mind is the calcium, iron, and the things which are the minerals we required for our body. So if you eat a lot of milk products, you'll get a good amount of calcium. If you eat other varieties of foods, then accordingly you will get this mineral. Correct. So this is something a mineral which may be coming to your mind the first. Then if I again go for, then you may be aware about the mineral systems and the minerals in the water. The water is not having minerals, so there is a less bone density and all. Is that the same thing what we are going to discuss here? No, we are not going to discuss that. When this is a perception of the viewing the things by what we call dietitians and all, or the food related peoples. So we are not going to discuss these minerals. This is not the mineral for us. For us, what we are considering is a mineral is all the naturally occurring, generally inorganic, solid crystalline substances which is having a specific chemical composition and physical properties and existing on the earth crust. We consider it as a mineral. Okay, so this is the definition says. What are the definition says? It says a mineral is a naturally occurring substance. It has to be solid. It has to be generally inorganic. That term is, we have added something before the inorganic term to generalize the term. Generally it is going to be inorganic, and it will have a specific chemical and physical properties and a proper composition. So that is a mineral for us. Seems interesting. Naturally occurring. What are the things naturally occurring on the surface of the earth? If I see natural things, there are tree, there are soil, there is water. Tree is a mineral? No, it is not a mineral because it is an organic thing. Water is a mineral? No, water is also not a mineral because it is not solid. Then what is a mineral? A mineral is, we can say it is a diamond, or we can say it's a gold, or we can say it's a quartz, or we can say it is a calcite, or we can say it is a tourmaline, or we can say it is a muscovite. I know that you are confused with these terminologies, but most of you will be very familiar with the term quartz. Have you heard the term quartz? Sometimes if you see the watch, which will be written on the watch, that is a quartz watch. And why it is quartz watch? Because there is a quartz crystal used in that watch, and quartz is having a particular physical property, physicoelectric property. Because of that property, we use that. And if you have heard the term quartz, then you must have heard the term silica. And when you heard about silica, you must be knowing about the sand, what is we are using in the construction, sand. The sand what you are using in the construction, which 90% is of quartz crystals, and we call it as silica. And if you happen to move out of your house and any construction site and take that reti, what you are using for the construction, that sand, and take it in your hand and see that where whatever you see in the crystals of light transparent, light white color or light pinkish color or a black color crystals that shining like a glass, that is quartz crystals. There's plenty of that, it is available on the surface of the earth. So that is a mineral. So mineral is something which is naturally forming on the surface of the earth, which is solid, which is generally inorganic, and which have a specific chemical composition. That material is called a mineral. What is the definition? A mineral is a naturally occurring, generally inorganic, solid crystalline substances having definite chemical composition, crystal system and physical properties. Chemical composition, crystal system and physical properties are together, and which will be natural, which will be solid, which will be generally inorganic. Naturally occurring means it has to naturally form. Solid, I have already said, water, we don't consider it as a mineral, but water in its natural forms, ice, naturally formed ice, we can consider it as a mineral. Correct. So if I get into a glacier, and if I'm walking over the glacier ice, so what I'm walking over, it is a mineral. But if I freeze that water in my freezer at home, because that is not a natural process, it is an artificial process, we are freezing that, so that we cannot consider as a mineral. Generally, inorganic is the term what we use because it should not have the organic compounds. That is what the term indicates. But there are so many different things in the earth surface which are organic in nature, which formed by organic compounds, but we still consider it as a mineral, like limestones, okay, and graphite. So that kind of things we consider, so that we use a term generally inorganic. And there are few exceptions, like mercury. Mercury, if you see that in the natural form, it is we get the mercury in liquid state. So that also we consider it as a mineral, even if it is not very strictly, because we are playing with the nature, we are defining something which is formed in the nature, and that is somewhere we have to provide some exceptions. So that is a mineral. So if I take you to the mineral is that, then what is this rock? Because at this moment people may not be able to differentiate what I'm talking about. I'm talking about mineral and I'm talking about a rock. So when I talk about mineral, people may be very immediately getting into the image of a rock. But then what is the difference between these two things? Difference is something like this. What you see on the screen, it is a cookies. So if I take this cookie is a rock. Okay. So the ingredients of this cookie, like the chocolate chips, what you can see on the screen, this ingredient what you see on the screen is a mineral. So this is one mineral. This is another mineral. This is mineral. This is mineral, this is mineral, and this is also mineral, and all these white things what you see here in the smaller things which forms a part of the things which becomes a mineral, and this cookie as all together we can call it as a rock. So what is a rock? Rock is, simply speaking, is the aggregation of minerals. There are so many minerals together which forms a rock. And if you need to see an actual example, what you see on the screen is a granite rock. This is a granite rock. And if I give a closer look into this granite, one portion, where what I will see is different varieties of minerals. One is this pink color, one is white color, one is black color. Okay, so out of that, if I look closer into one particular mineral, then I'll see that this is actually a composition of different different elements. Okay, so that is what we are talking about. We are talking about a rock. Rock is an aggregation of minerals. It can be a single mineral or it can be a multiple mineral. And the mineral is what? Mineral is something which is having a uniform composition and naturally forming. Then we are talking about naturally forming. Then where is it forming actually? Where is it forming? The things are forming at different parts. The first portion is that the mineral from the magma. You remember these pictures where the magma is coming up. So here the magma is coming up. All these parts where the magma is coming up. What is that magma? Magma is a molten rock. What is that molten rock? What is that material? That material is a lot of number of different varieties of chemical components. So that chemical components come up and which forms a rock, and when it forms a rock, what actually forming is the small minerals, and that small minerals combined together will form a rock. Okay, so this magma, if it flows, if you remember, I feel that if you remember that how the magma was flowing on the surface, so that process, all that processes are actually creating the rock, and when it is creating the rock, it is actually forming a rock, a mineral. So that is the first process. We call it as the formation of mineral from magma. The cooling of magma, the process we call it as a solidification process. Okay, that liquid molten rock is converting into a solid rock, so that process we call it as a solidification process. Similarly, if you see, this is a volcanic eruption, and during a volcanic eruption, you must have seen the recent eruptions that it creates a lot of materials, lot of gaseous materials that spread on the atmosphere. So that kind of major eruptions which is coming up. But in some cases, if this kind of gases which are trapping within this large amount of rock, there is some amount of gas which trapped inside that. So what will happen to that? When we are talking about this gas, what is this gas composed of? That gas still composed of number of different varieties of elements in it. So these gases will start forming start crystallizing. Okay, so this kind of beautiful crystals, it will form inside that part. So that process we call it as a formation of mineral. So what it is forming here from the gas, this is a mineral. So that mineral is actually formed from the gas, whereas the surrounded, the outer things, this all portion of the rock or the part of the mineral is made from the solid. So this is the process of solidification, and this is the process of sublimation. Now there is one more process, we call it as the recrystallization. Recrystallization is nothing but, if you remember, that this is a plate which is moving down, or the layer of rock which is moving down, and when it is moving down, it gets accepted into a huge amount of forces, and that forces are also with a huge amount of heat, and this high amount of heat and pressure which will convert the rock into another mineral or another rock. Converting a rock into another rock means converting a group of minerals into another minerals, which is simple, like when you must have seen that how the bricks are made. What they do is that they make a brick, they make the brick into the mold and make it the shape, and they'll dry it in sunlight for some time. When it is semi-solid state, they put it in the heat at a very high temperature, and when it come out of that, it is becoming a very solid substance. That is how our bricks are made. So that is a process we call it as a metamorphism. The metamorphism is that in the solid state, because that clay what you are taking for the brick, we are not melting it. We are still in the solid state only. With the conversion or the compaction which is happening in that body of that solid state is because of the high pressure and temperature in solid state only. They are not converting into liquid, or it is not melting. So that process we call it as a metamorphism. So that metamorphic process also will produce number of different varieties of rocks. So that becomes the third process of formation of mineral. First process is from the liquid which forms solid. Second process is from the gases which forms solid. Third process is from the solid which forms a solid. And fourth process is the process of formation of mineral from the solution, that is the precipitation process. Precipitation process, if I need to give you an example, if you happen to get into your overhead water tank, and if it is after a few years, if you are looking into the water tank, what you see is a lot of deposits on the bottom of the water tank. What is that deposit? That deposits are actually, where is it coming from? If you are using a municipality water, then that deposit would be less, but if you are using a borewell water, then the deposit will be huge. Where does that material come from? That materials are coming from the waters what we are storing on the water tank. And what is that particular material happening? What is it happening? It is precipitating. So precipitation is the formation of solid substances from the water or from the solution. So if you can imagine that our surface is covered with a huge amount of volume of water under the sea. So how much amount of precipitation will be there on the bottom of the sea? So that is also actually producing number of different varieties of minerals. But out of this, the major one and the variety of large amount of minerals are produced from the process of magma or from the cooling of magma. Rest of the processes are good, they produce number of varieties, but the diversity and variety are what we are getting it is from the process of cooling of magma. Correct. So this is the process of formation of a mineral, and we discussed what is a mineral. Now when you are talking about a mineral, we can study the different characteristics of this mineral. Okay, first one, it is just like that when we need to examine a mineral. Now, when I see a mineral, it is almost something beautiful colored mineral. Now, if I need to identify that which mineral is it, then I have different processes to do that. What are those processes? First one, it is the physical process. It is the physical examination of the mineral. Take that mineral in your hand, see that, smell that, taste that, whatever you can do. That process is called the physical properties or the physical examination. Then there is another process which is called a optical process. And the third one, it is called the chemical process. Okay, so chemical properties, physical properties, and optical properties. These are the three main properties which can help us to identify a mineral. For example, if I take a similar case that someone got ill, so they are having a high fever and some asinus problem. So now we are going to a doctor. What the doctor will do? First, the doctor will check your pulse, then you check your temperature, you check your pressure, oxygen, oximeter you will use. So what he is doing is basically a physical examination of that patient. Now he suspects that okay, this is something different. Then what he will suggest? He will suggest you to go for a blood test. So the test, when you are going for the blood test, what it is doing is a study or some detailed study. So this detailed study may be under a microscope, maybe under an MRI scan, and it may be under a detailed X-ray or any of that process. So similarly, this is the stage where we study the properties of a mineral. So when I get a mineral, first thing is that to see the mineral and identify the physical properties. Physical properties that whatever we see on the surface of that mineral in the hand specimen, we take it in the hand and we observe that. That is the properties. Then if you have some confusion that okay, this is not that particular mineral what I am looking at, I may have a confusion, then I go for a study on optical property. So in study on optical property, we will make a thin section of the slide. Thin section of the rock means thin, it will make a very small 30 micron size thin layer of that rock, and we will paste it in a slide and we will study it under a microscope. So microscope, when we see, the light will penetrate to this rock and that will show some characteristics. So that property we call it as a optical properties. But still, if you are not able to do, then we will do is that we will take that mineral, we will grind it into small powder and we will dilute, we will digest it into some acids and will become a solution, and we will study it into the modern geochemical instruments to identify the chemical composition of that metal. Or we observe that small crystals in a XRD instrument or any other instrument to understand the chemical composition of that mineral. So that processes, we call it as a chemical property of the metal. Okay, so we will be briefly discussing all these properties one by one: physical property, optical property, and the chemical properties of a mineral. Correct. So let us see the first one, that is optical property. So when I'm talking about optical property is the property of the mineral in the property or the characteristic shown by a body of the mineral. When you take the mineral, so that it shows that is a physical property. So these physical properties are classified into different categories. First one is character depends on light, then character depends on sense, then character depends on internal atomic structure. Internal atomic structure means you know that when you take some solid substances. These solid substances are made up of small electrons and protons. Okay, so electron, protons, neutrons, which are there inside that becomes the solid substance. So the internal arrangement of that materials is actually give the property on this. So this what you see on this the screen is a namak, salt. Okay, so it is sodium chloride, NaCl. So that is how it is having a particular property because of the internal arrangement. So that internal arrangement gives different properties to a mineral, like form, habit, hardness, cleavage, fracture, tenacity, etc. Then there are properties which are based on the specific gravity. Then there are properties which are based on the heat or the fusibility. Then there are properties which are depending upon the magnetism. Then there are properties which are depending upon the electricity, and properties which are depending upon the radioactivity. So these are the basic physical properties when you are studying a mineral in detail. But we may not be going into that much detail for our discussion. So what we should see is, as a civil engineer, when we see a mineral, we should at least get an idea whether this mineral is something worth for me or not, whether the mineral is something going to damage my building or my soil or my site or not. So that is what the basic understanding a civil engineer should get from the mineralogy. So we may not be going into very depth or the details of all these topics. Rather, we will generalize this discussion and we will see that what are the basic, some of the basic physical properties which can help us to identify a mineral. So this is the exclusive list of properties, physical properties that we can study about a mineral. But as a civil engineer, we are not going into the depth of this topic. Rather, we will briefly discuss what are these properties, some of the common and the important properties. Like color we will discuss, streak we will discuss, color, streak, luster. Then we will discuss something about form and habit. We'll discuss hardness, we'll discuss cleavage and fracture. So these are other properties which are the body of the mineral, which are related to the body of the mineral, but we may not be going into the details because our objective for studying a mineral is not to get into the depth of that. Rather, as a civil engineer, we should have a general idea about the mineral characteristics. So that is our purpose. So for that purpose, we will be discussing these many properties in brief. Okay. So the first property is the color of a mineral. You know that the color of any object is depending upon that what spectrum of light, that you know that the white light can be divided into violet, indigo, blue, green, yellow, orange, red. So this is the spectrum of colors which is available in a white light, and when it falls on any object, some part of this will be absorbed by the object and some part will be reflected by the object. So the object what we see in black color, that means it absorbs all the spectrums of the wavelength which is in the white light, whereas the things what we see in white color, that indicates all the spectrums of wavelengths are reflected back, so our eyes detect that as a white object. Same thing is applicable here. In the case of a mineral, the mineral may be of different color. Okay, so if you see here on the screen, what we are observing here, it is the gem varieties of different gemstones or the minerals which are gem varieties. So we can see that different colors of minerals we can observe. But one thing is very important at this point: when we are studying a mineral, we usually don't take the color of that mineral as a diagnostic property. Why? Because any mineral which is supposed to be a very pure in quality and it is supposed to be a colorless in nature, a small amount of impurity can give some different color to that. Correct. So for example, if I take a mineral that is called quartz, this is what mostly we see are the gem varieties, but if you take the mineral quartz is available in different varying varieties, starting from the black
quartz to white quartz, smoky quartz, pink quartz, green quartz. So these all different varieties of colors are due to some amount of impurities or some amount of chemicals which are adding into that. But that doesn't have any relation with the actual mineralogical composition of that, actual chemical composition of that mineral. So we usually, as a geologist, people who are trying to identify the properties of a mineral, we don't take this color as a diagnostic property. We don't take this color as a to identify a mineral. Rather, we take it as a property of a mineral, whereas we are more depending on the streak property. You know what is streak? I don't know whether you people have seen it or not, because today, in these days, whether there is more advanced instruments are available, but if you have gone to any old jewelry and if you give them your gold, so what they used to do is that they take the gold and they will scratch it on some plate, and the fellow will say that, okay, this gold is not pure, this gold is mixed. So the purity of the gold used to identify by scratching the gold against some surface. Same thing what we are doing here. If you are having a mineral, we take that mineral and scratch that mineral against a porcelain plate. We call it as a streak plate. So what is the color of that powder that appears on the surface of that streak plate? We call it as a streak property of that mineral. So this is more diagnostic in nature, because when the light falls on the surface of a mineral, it is reflecting in different ways because it is a solid compact surface. But when it makes into a small powder, small layer of powder, what happens? The light can penetrate and it can reflect, and this becomes a diagnostic or a property which we can use to identify a mineral. So for example, if you see, this is a mineral called pyrite. Pyrite, if you see, so the color of this pyrite is like something like yellowish, goldish color. But if you scratch it against the streak plate, the color which comes on the streak plate is a black streak. So this is the identification property of a pyrite. By taking the streak, we can identify the pyrite. So streak is what? Streak is the color of the powder of the mineral when it scratch against a streak plate. So what is a streak plate? Streak plate is a porcelain unglazed fired porcelain plate which is used for a geologist to identify the mineral, which is having a hardness of around 6.5. Okay. Now that is the streak property. Similarly, there are property called luster. You know, all the lusters are not gold. You must have heard the saying. So the luster is what? Luster is the amount of light which is reflecting from the surface of the earth. You can see these two examples, two samples what you see on the surface. One, it gives a reflecting effect, it gives a shining effect, whereas on the other one, if you see, it doesn't give a shining effect, it is a dull, something like dull. So this shine, how much amount of shine? If you see a diamond is very very huge amount of reflection from the surface. So that is what the property of diamond. Whereas if you see iron is not having that much reflection. So similarly, the mineral, when we get it from the surface, that has different amount of reflection from the surface. So based on that reflection, we identify the mineral. So some of the minerals which shows metallic luster, some of the minerals which shows non-metallic luster. So these all are compared with some other characteristics of this shining, and we study the properties. Like if you see the vitreous luster means the object or the mineral which shines like a glass. Okay, so it shines like a glass, we call it as a vitreous luster. So similarly, resinous luster is a property or the shine of the mineral which is similar to a resin. Correct? Pearly luster, silky luster, adamantine luster. These all are the terms which are we use to with reference to. Silky luster means the object or the mineral is shining like a silk like shining. So these are the properties which can be used to identify the mineral. We can see that if the diamond like shining is coming on the surface of the mineral, so we can say that okay, this may be diamond, but other properties we need to then check to identify whether that is a diamond or not. Only one property may not be able to identify, but there are few minerals which will have a diagnostic property, that may be a luster. Similarly, based on the intensity, so there are either a dull luster or splendid luster or a shiny luster. So this is basically based on the intensity, and this is basically based on the reflection, kind of reflection, what kind of reflection it gives. Okay, so this is okay, so this is the luster property. Now the next property of a mineral, which is called the hardness. What is hardness? Hardness is the resistance offered by a mineral against abrasion or scratching. Okay, for example, if you sit with a, if you are sitting in the classroom and if there is a the table which is having a lamination, you sometimes may try to scratch the surface of that table with your nail, and what you observe that it doesn't make any difference on the scale, because the surface of that table which is harder than that of a your nail. But compared to that, if you take a rock or a keel or a knife, and if you scratch on the surface of the table creates small depression or a small scratch on the surface. What is the meaning? The meaning is that the table is softer than that of a knife, and it is harder than that of a nail. So this kind of relative property, what is it called? Relative property of a mineral is called a hardness property, in this case of Mohs scale of hardness. It is nothing but it is simply there's a scientist Moh. What he did, he identified, we took all these minerals and scratched against others. Each one they scratched, and he arranged the minerals in such a way that the increasing of the resistance of the surface. And he identified, out of that all minerals he identified 10 minerals. What are those 10 minerals? Talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. So these all 10 minerals he identified, and he arranged it according to its increasing resistance. So here it means talc is a mineral which is having a lowest hardness in terms of Mohs scale of hardness, whereas diamond is the mineral which is having the highest hardness in case of Mohs scale of hardness. And this scale of arrangement of this mineral is in relative hardness. What is it given here? This is the relative hardness. And if you see the absolute hardness value of this is can be identified. So these absolute values are shown in this figure here. So talc, if you take it, is here, and a diamond. So it is not a linear scale. It is not arranged in a linear way. Like if you see the hardness of corundum and diamond, it is around 8 times, 7 times, 6 times or 7 times than that of the corundum. Okay, so that varies. Okay. So the hardness scale, the Mohs scale of hardness, which is identified based on the relative hardness, and the hardness property, when you take the hardness property of the mineral, is called an anisotropic property. What does it mean, an anisotropic property? An anisotropic property is that if I take a mineral, okay, and if I try to identify the hardness of that mineral by scratching with any of this mineral from the hardness box and did a scratching, so here I got a hardness value of 6. Now I took the same mineral and I scratched this way, so that is not creating a hardness. So the hardness on this direction, that we call it as the y direction, is more than that of the hardness that of x direction. So this kind of property. So the direction of measurement of hardness which varies the amount of hardness value, or the relative amount of hardness value. So that we call it as a anisotropic property. Okay. So, but it doesn't mean that it doesn't mean that if I find out the hardness in one direction, it got 1, and when I found it on the other direction, it got 10. So that much variation may not be expected. For example, kyanite is a mineral which is showing 2 different hardnesses when you find the hardness in different directions. So that all depending upon the internal atomic arrangement of the minerals. Okay, so this is called a hardness scale. So what are the properties we discussed till now? We discussed about color, we discussed about luster, we discussed about streak, and we discussed about the hardness. Okay, and now this is small scale of hardness, and if I compare the small scale of hardness with the well-known objects like our fingernail, which is having a hardness of around 2.5 in the case of hardness scale, and the copper coin, which is having a hardness of around 3.5. Wire nail means this keel, what we talk, which is having a hardness of 4.5. Glass or a knife blade, which is around 5.5, and the streak plate, what a geologist used to identify the streak, which is having a hardness of 6.5. Okay, so this is the hardness of known objects. So when the student or a geologist, when you are in the field, we always don't carry a hardness box and all these minerals in its order. And in that case, when you get a mineral, not a mineral, when you get a rock, and the identification of the rock depends on that what kind of minerals are present in the in the rock, like the cookies we have seen. So that we call that it is a chocolate cookies because of the chocolate pieces in that. So to identify a rock with its name, or to name a rock with its mineralogical composition, identification of mineral is the first process. So identifying that mineral in the rock will be done by any of these objects, whatever is available. And if you're doing it in the laboratory, then that time we may be using the proper hardness box, or we can even find out the hardness by laboratory experiment. Correct. So this is the hardness property of the mineral. Now the next property, which is depending upon the characters of internal atomic structure, we call it as a form. Form is nothing but it is how the crystals are developed in the mineral. So it is the geometry of the mineral. So for example, if you see this image on the screen, this is a crystal of amethyst. But you can observe here the one side which is very properly formed, but other side if you see that it is not very properly formed. But if you see the second image, see this image, it is very properly formed in the all parts. Okay, we can see the edges, we can see the corners, we can see the faces. Okay, so all these parts we are very properly able to see. So that means this crystal is very properly formed, but this crystal is not very properly formed. What is the difference in here? Why does it not form properly? Because while forming this crystal, there were some disturbances, and or it may be the availability of the chemical, it may be the temperature, it may be the local settings, anything, something which actually got disturbed, and the mineral could not form in its full proper crystal form. Okay, so whereas the other category we call it as a opal, this is an amorphous substance. It doesn't have any crystal. We don't be able to find something like a crystal shape in this opal. So this we call it as a amorphous substance. You must have studied in school days, glass is an amorphous substance. Why it is amorphous? Because it is not getting the sufficient amount to cool from a liquid and properly form the crystal. As a result, it doesn't become a proper crystal. Whereas there is one more category, we call it as a cryptocrystalline variety. So cryptocrystalline variety is that the crystals are there in this, but the crystals are such a small, because when you see that when I draw this line, this is one layer of mineral, and this layer will have lakhs of small fractions of minerals in it. That means the crystals are there, and the crystals are microcrystalline. They are very fine crystals. Okay, here this one sample is one crystal. Here this one sample is one crystal. But here in this case, the one sample is having millions of crystals. Got the point? So that kind of crystals we call it as a cryptocrystalline varieties. So the minerals may be sometimes crystallized with how proper well developed crystals like the garnet what you see here. Okay, the mineral may be crystalline, that means which is having the sign of crystallinity, but it is not very well developed. The crystal may be of amorphous, that is it is not formed at all, formed as a crystal at all. Then the crystal may be cryptocrystalline, where the crystals are very fine. Okay, so these all things actually indicates the direction, or we get an information that in what condition the minerals was forming, how the minerals were forming and what conditions were there, whether the required condition for the formation of the mineral was there while it forming. While it forming where? When it was coming out of the magma, coming through a volcano, or whether it is formed below the ground. If it is forming below the ground at a kilometer, 5 kilometer down, the temperature pressure conditions are stable. It is very high temperature and the cooling process is very slow. But the magma which comes out of the surface flowing on the surface, that time the temperature is a very sudden drop. As a result, the rock will not be able to form in a calm and quite cool environment. Rather, it is the very rapid process. So that rapid process will not produce proper crystals. What will happen? It will not produce proper crystals, and as a result, that will be having more amount of amorphous minerals in it. Okay, so these are the things we get. And if you get a rock which is a volcanic in nature, volcanic means it comes out of the surface and cool down. If you remember the video what you have seen, the volcano which was flowing on the surface, so that rocks which are forming will have mostly amorphous minerals in it, comparing to the rocks which are forming in a deeper part. The rock which is forming in a deeper part is called a one example is a granite, we use extensively for the construction activity. But basalt is widely available, but it is a volcanic rock which is on the surface, forming on the surface. So that will have more amorphous minerals in that, and it doesn't have crystals, so it is not at all beautiful, and we are not using it as the same way we use the granite. So these are the differences we need to understand in the case of a minerals. Now, based on the crystal growth, there are a number of different habits. Okay, so what I'm going to do is that I'm just browsing through the images. There are a number of different varieties of habits, the development of individual crystals or in a group of crystals which forms a different aggregations. So there are some individual crystals and the aggregation of crystals. I will browse through it quickly. So these are all the different varieties of minerals which is actually existing on the surface of the earth. Okay, so this actually forms as the way we see here. So this we call it as acicular structure, acicular form, or a bladed form, fibrous form. Okay, so these are all different varieties of forms what we are seeing. So mica is a mineral. You must have heard in the mica paint, which mica marble. What is that mica marble? This mineral is added to that. Why it is so? Because it is having this particular property, and it is having that property which is used for the paint industry. So similarly, it is the structure or the form it is having a foliated. It can come out as a single layers. So lamellar, prismatic. So just these are all the different reticulated, scaly, tabular, and crystal aggregate. Sometimes it may be a amygdaloidal, or it may be a botryoidal. Botryoidal is nothing but amygdaloidal means is an almond shaped aggregates, and botryoidal means it's a bunch of grape like structure. Columnar means it is like a column. Then concentric and nodular, so we'll be able to see the concentric formation of minerals. Dendritic pattern is the branch like pattern what we see. Dunite, which was a granular form. Then lenticular, malachite is a particular mammillated structure which is shown. Mammillated form it is shown, and it is a radiating form, or it's sometimes like a hematite of a kidney like structure, or stellite which calls a fibrous radiating forms, wiry forms which is very common in the native copper. Okay, so these are all different varieties how we get the minerals on the surface. Okay, so it is these all things what you see on the screen are natural photographs of minerals. So we get the minerals in these particular forms. So this is all other indications of the process of formation. Now there is another property, very interesting property, that is the cleavage property. So cleavage property means it is the tendency of a mineral to split along some definite planes. For example, if you see here, this is a mineral. Okay, this is a mineral. This mineral, this is one layer what you see on the surface, and there is another layer on below that. And this layer on one direction, the surface parallel to the surface, which are all bounded together. But this one layer is bounded to another layer with a weak bond. It's like a page when you take a book. So if you see the page, this is one page and this is another page. So these two pages are bounded together with a weak bond. As a result, what happens? We are able to take out the layers of this mineral one by one. So this one layer I can take out, this second layer I can take out, this is a third layer, so this is a fourth layer. So these three layers I can take out. So the ability of removing these layers, or the property of the mineral which is having a inbuilt, okay, inbuilt, this is actually have inbuilt weak bond. You know, there are different kind of bondings between the particles. So this bondings between these particles which are weak, as a result there would be a natural weak layer through which I can take out the mineral into sheets, or we can break the mineral into mineral apart. So that we call it as a cleavage property of the mineral. Correct? So this is called a cleavage property of the mineral. What is the cleavage? Cleavage property. Cleavage is the tendency of a mineral to split along some definite planes. Okay, so this is actually related to the form and internal atomic structure of the mineral. So this mineral what you see on the surface, this is on the screen, it is muscovite or biotite. This is biotite, and we are able to take out these individual layers of biotite by using a small knife. So we use the terminology say perfect, eminent, good, distinct, poor, indistinct to represent the cleavage character of that mineral. The next property is called the fracture. Fracture, you know what is a fracture? Fracture is what? Fracture is breaking. I fractured my my hand, leg. But we are not talking about that fracture. When you break a mineral, how the surface of that mineral appears. Okay, just an example if I take, if I break a glass and if you see the broken portion of that glass, it appears something like this. Correct. It will not be a plain surface, it will be a curved surface. There will be some curved lines on that. Okay, so that is a particular character of the breaking of glass. The same way, you take a wood and break it and see the broken part. What you will see? You will see some sharp edges, lenticles on the wood when you break it too. So that is a different property. Okay, so this glass doesn't shows or break like wood, or wood doesn't break like glass. Okay, so this property is called the fracture property. What is the property? The property of a mineral, or the character of a broken surface of the mineral, is called a fracture property. Okay, so fracture, so we can break any rock. When you break that, see the surface, how it appears. Whether it is breaking like glass, we call it as conchoidal fracture. Whether the broken surface is having an even nature, which is having some definite planes and it is evenly breaking, we call it as an even fracture. When it is uneven, it is not having an even nature, or splintery, forming sharp splinters, fibrous, hackly, and earthy. Okay, so these are different terminologies. Nothing but it's terminologies. Earthy means it is very dull like chalk. Hackly, it jagged and elevated surfaces. If you break an iron bar, so you'll see that the surface is not very smooth, and rather it will have some elevated surfaces. So that kind of fibrous, example I told you, that the wood when you break, we get this fibrous things. So there are minerals which breaks and shows the property on the broken surface, that property we call it as a fracture property. Okay, so these are the main properties of physical properties what we are concerned about in this chapter.